Our next speaker is Dario Pasquali.
Yeah.
He's presenting No Robots is an Island, an always-on cognitive architecture for social context awareness in dynamic environments. Thank you very much.
Thank you so much for the introduction. We are the sum total of our experiences. So everything we pass through, every person we meet in our life, shape who we are today. And that's exactly what we wanted also for our little ICAB. In the ICOG framework, we are working on a cognitive architecture to enable this little guy to learn autonomously from his own first-person experiences. And in this journey, we found out that modern AI maybe is not enough. So, you know, AI today is all about dumping as many data as possible into a disembodied agent, hoping that the real cases will fall within the training distribution. But as humans, we don't work like that. We are born with a little tiny spark of knowledge, a set of phylogenetic skills that we grow day after day through first-hand experience until we build our very own ontogenetic knowledge. And if you think about what is this spark for a robot, we think that this is the cognitive architecture. And so we came out with this one. It's a totally work in progress project, incremental, that for now I'm going to present you the milestone that we reached. At the moment, this architecture is designed to do three simple things. It's meant to be always on, so always active, always perceiving, and always ready to interact with humans. It perceives its own environment in a multidimensional way, the multimodal way, and learns, at least try to learn, from its own experiences. So let's decompose this architecture. We embodied it in our little Alfie, we called it. It's an ICAB head mounted on a 3D printed body of an ICAB. It can gaze, it can hear, it can speak, it can show facial expression. And for now, its behavior is really simple, just reactive. It looks for faces in the scene, and when it finds a face, it will track it, just that. What is important is the other three models. On the perception, we process in real time the video and audio. And from these two data streams, we compute 5 very simple features that we deem to be the minimal set of features that could kickstart learning. We have the number of faces, the subset of people that are looking straight, mutual gazing to the robot, the amount of noise from both right and left ear, the amount of light, and the amount of motion. We take all of this together, both raw and processed data. We add the joint state of the head, and we attach a timestamp to it, and we call it an event. Then the episode segmentation module is in charge of segmenting this continuous flow of event in meaningful chunk of experience that will preserve a consistent context. We call this episode. And to do so, we used another simple method about novelty. So the idea is that if I'm leaving a context now, what I'm leaving is more or less within the same distribution. While when something new happens, something in my perception will change. And that's exactly what we do. So the agent keeps track of the mean and standard deviation of the faces, audio, and motion, and compares each new event with this distribution. If the event falls within the distribution, it's added to the episode. Otherwise, if it's an outlier, we close the current episode and start a new one. What happens to this episode? We encode it in memory. And to do so, we applied an embedding encoding in order to efficiently store it. So we take the raw video, the raw audio from both channels. We use low fast for the video and big for the audio, and we compute a 528 long embedding. Also, we store the average of the features of the perception. These embedding, daily or on demand, are consolidated in order to learn long-term association between the episode that the robot perceived in its own life. And so we do this by reducing the dimensionality of the embeddings with UMAP, going to a 2D or 3D representation, and trying to clustering this episode into a representation that will hopefully make some sense. And this reduction clustering cycle is repeated, looking for the best hyperparameters that maximize the silhouette score of the clusters. So to test this, we went in a sort of European validation tour. So we started from IIT lab in Genova, and we brought our system within the ICAB as a demonstration to some of the major robotics and computer science conferences in Europe. And in all these places, we just deployed the robot for a few days, let it observe the environment in front of it without any supervision. And the point is validating the segmentation, the encoding, and the consolidation. So, did it work? Today I'm going to present you the IIT and the Humanoids validation. In our open space, it stayed active for 4 days, from 10 a.m. to 6 p.m. We asked our colleagues to just keep their routine. And we placed it in our main office, near to our coffee machine. And this is the evolution of the associative memory of the robot during these 4 days. So you can see that just from the very first day, something starts to appear. And this representation evolves until we reach day 4, where we have a clear distinction between two clusters, the orange one and the blue one. So we don't have labels. So how we can give some sense to this? Use statistics. So we compared the two clusters based on the perception. And so we found out that the orange episodes are related to episodes with a lot of number of faces, a lot of motion, a lot of gaze, and a lot of audio. So highly lively, with a lot of human activity moments, while the calm ones are longer, more relaxed, with a lot of more illumination. Okay, so, but an office is quite predictable. So what if we go to a way more chaotic context, which is a conference? So this is the evolution of the memory in these days, and you can see that we have kind of the same representation. And also statistically, we have the orange one with high faces, motion, noise, etc., while the blue ones are like just lower than the orange one. And last but not least, we asked, okay, in both venues, we started from scratch. What if we put everything together? We reduce the system, we reduce the space, we learn a representation, will make some sense? And well, it does. So this is the memory, the representation of the memory, the episode in memory, putting everything together. And those color and shapes, I didn't place them. So those are the labels of HDB scan. And you can see a clear distinction between the labels in the lab and at the conference, and the statistic difference is preserved. So we have still lively and calm kind of episodes. So what? Take-home messages. In just a few days, 3-4 days, this system is able to model and learn a very, very fundamental distinction to moments in which there is a high human activity and low human activity. And this seems really simple, but we think this is the foundation of behavior, because if you don't know when there is someone to interact to, and if this is the good moment to interact with someone, you cannot behave. And using this memory, we believe that an agent, a robot, could behave proactively in a consistent way with the social context and the location it is in. Okay, I invite you to read the paper, because we put a really truthful discussion on what we would love to do in the near future. But now I'm going to highlight you the 2 main points that we are going to address. First, of course, this guy doesn't act. Okay, he's just there on a desk, looking around. And so what we're going to do in the next video, we're actually doing right now, is to enable it to act proactively in the environment, to select which action it should perform, and we are going also to move it, porting to the full ICAP body. I don't mean that just that is not enough, but with more like arms and torso, we could do way more. And second, it doesn't know what is good and what is bad. So we are going to add a value system, a motivation, internal and intrinsic and extrinsic, and so that this agent can decide which action to perform in alignment with its own goal. And with this I conclude. I would like to thank you, all the collaborators that work with me on this project, both on development, on bringing the robot around Europe, on suggestion, advice, and supervision. And I also want to thank you for your attention. I invite you to scan that QR code. You will find the paper and a little podcast about it. And if you have any question, I'm here for you. Thank you. Yeah.
Up there.
Thank you for the great talk. It's a bit of a cheeky question, but maybe it's my lack of vision, but I was wondering, what does it add over just having, for example, the number of decibels in a room that is quiet versus very lively? Wouldn't that already do the job?
Sorry, I missed instead of having what, the number of?
If you measure, the decibels or the complexity of the noise.
It's not literally the decibel, it's the root mean square of the audio.
No, I understand what he's doing. I'm saying, what does that add over a simple measure like measuring the noise in the room?
I don't know. So
okay.
I truly don't know. So the point is that we selected those features as what we thought could be the good feature based on literature, based on our experience, based on all the discussion what we did into the ICOG initiative. But maybe adding the decibel could be another feature that could be super relevant. We don't know yet.
Thank you.
Yeah, thank you so much for the talk. My question was related to, so as you mentioned correctly, that the context is actually the outcome of the history, like what has happened so far.
Yes.
I was like actually thinking into the line of first that how do you recognize the segmentation, like where the event segmentation lies?
Yeah.
So that's the first one. The second one I was also thinking about, like how do you measure the rate of change of this context? For example, initially the context, for example, it's static, where there is nothing more than happening. But then when it changes to some, where the people now started talking and it's more active in a sense. So can we also measure that changes? And if we measure it, what should be the the window of the window of this change that would consider, if possible? That's difficult, I know. But
so I missed the first question, but first I'm going to answer the second. Thank you. That's a really good question. So in our idea, these two moments should be presented at two different episodes belonging to different clusters. But now you see a representation that is bidimensional, like two clusters. Maybe staying alive for more time, a different, more deep representation should appear. Also adding semantic, for instance. Now the robot knows that there are 5 people, 2 are looking at them, there is some kind of noise, motion, and a light, but it doesn't know who is there, what they're doing, which objects are there, if they're talking to him or not. So I think that to going deeper and evaluating this kind of transaction, we need to go deeper also in the way that the robot perceives the world and integrates this perception in its own memory. Okay? Can you repeat the first question?
Yeah, it was about the event segmentation.
Yes.
Like how so that's a going debate in cognitive science, like where exactly the boundary of event lies. So in that context, I was thinking but it's still possible through this mechanism, through this measure, to find those parameters as well.
I hope so. I hope so. Yeah. Now what I show you about novelty, what we call novelty, actually segment the episode based on something new is happening. Okay, let's shut down what I was doing before and focus on this new thing. But also this can be improved. Like for instance, rather than just shutting down the episode and start a new one, we could maintain the attention, sustain the attention, and enlarge this window of focus because something interesting is happening. And so I should focus on that and then cut. So that could be another possibility. I hope that you're welcome.
Thank you. First, Xavier, short question, and then Lola.
Yes.
And I would also like to invite the next speaker, please, to come forward. Thank you.
Yes, so very short question. So I'm not sure I understood, because you talk about grid search, but is it possible to do other kind of research? Because grid search is quite suboptimal.
Can you repeat, please? Sorry.
So you talk about doing grid search.
Grid search, yes.
Yes, but did you try other random search, which is more optimal than grid search?
No, we did not try other methods. We just so you mean this process in which we look for the best silhouette score, right? No?
Yeah.
Okay. Yeah. No, we just tried that model, just that method. We didn't try different methods.
Okay. Thank you.
We tried different score actually. The silhouette was the one that gave the best results. I mean, more interesting to describe and to evaluate. All the other methods could be interesting, but that's what we did.
Okay. Yeah. Thank you for the very interesting talk. For your future work, you mentioned that you were thinking about in values, and so would you have already some kind of values you would like to add, and what do you expect that would change? I mean, and how would you kind of make that compatible with like open-endedness?
Thank you so much. So, of course, we already have a lot of idea. And what we want to do is, I don't know if someone yesterday attended Alessandra Sciutti talk in the workshop, various workshop. So the idea is that in our lab, we have a lot of contribution about internal motivation, intrinsic goal, and way to lead the behavioral robot based on which are the goals, or is falling down, which are the goals. So the idea is to modeling this kind of internal intrinsic motivation that could be a comfort, could be an homeostasis based on energy, could be the desire of curiosity, exploring the world. And I think that what is important, is going to be important for me personally, is how this motivation is going to change the way we model the episode in memory. Because when we live in our life, we can perceive the same thing in two different ways based on how we feel it. Like if I'm experiencing this moment, I'm scared, but another person could be really happy and enthusiastic. And those two kind of events could be completely different mapped and associated in my memory based on how I feel them. And labeling the episodes based on how was my internal state in that very moment in which I perceived and experienced it could completely change how the memory is formed and then retrieved. Thank you.
Thank you very much, Dario.
You're welcome.